Let's take a look at negative exponents. And the first thing that you have to understand is that we never want to have an answer with a negative exponent in it. So after you've done all of your work and you see that your answer has a negative exponent in it, this is what you need to do. Move it across the fraction bar. If you don't see a fraction bar, like these right here, then come right over here and make a fraction bar. Move the base and its variable below it. But the problem is that we don't want it to be a negative exponent. So what you do is that if it was a negative exponent here, when you move it down here, just take the negative sign off. That's all you have to do. So x to the negative fifth becomes x to the fifth on the bottom part of the fraction. And if there's nothing left upstairs, just put a 1. So how can I make a to the negative third into a positive exponent? Draw a fraction bar and put it downstairs. And put a 1 on top since nothing is there. So let's go through these others. Now technically 2 to the second power is 4, so 2 to the negative second power, once we move it downstairs, it actually becomes 1/4. So let's take a look and see why that happens. Yesterday we looked at 2 to the fifth all the way down to 2 to the 0 power equals 1, and we're going to pick up with that train of thought. What we realized yesterday is that you could take the base, the 2, and divide 32 by the base, in this case 2. 32 divided by 2, it got us down to what 2 to the fourth is, 16. So if I take the base and divide 16 by 2, we get 8. Divide it by 2 and we get 4. Divide it by 2 and we get 2. Divide it by 2 and we get 1. That's the reason that we've proven that 2 to the 0 power is 1. But now just take 1 and divide it by 2 and we'll get down here. Well, what's 1 divided by 2? Well, there it is, 1 divided by 2. It's 1/2 or 0.5. It's not a negative number. That negative exponent does not make the answer negative. It just makes it very small. It makes it less than 1. Now take 1/2 and divide it by 2. And you'll see it 1/2 divided by 2 is 1/4. Well, that's what we already found out by just taking our little 2 to the negative second power and sliding it down to the bottom of a denominator. And then I know 2 to the second power is the 4, so we've already proven that 2 to the negative second power is 1/4, but that's where it's coming from. And so how about we just do this? Let's just go and take this one. Let's just put a little bit of space here, and let's put a 1 over 2 to the third power. And 2 to the third power is 8, so this would be 1/8. If I take 1/4 and divide it by 2, I should get 1/8. And there we have it. 1/4 divided by 2 really is 1/8. And it just keeps going. But I can also show you this pattern. 2 to the second power is 4, but 2 to the negative second power, we take that 4 and we just put it on the bottom. 2 to the third power is 8. Well, 2 to the negative third power becomes that 8 on the bottom underneath the 1. So 2 to the fourth is 16. So 2 to the negative fourth would be 1/16. 2 to the fifth is 32. 2 to the negative fifth is 1/32. So that's what's happening there. So if I wanted to do this right here, technically, what I could do is I could say, hey, 3 to the fourth power is 81, right? And then I could just make it to where it's 1 over 81, right? 3 to the positive fourth would be 81, so 3 to the negative fourth would be 1 over 81. Or follow my trick, put this one down here at the bottom, and then find out what 3 to the fourth is, which we already know it's 81. Now, these last two, this is where it gets into a little bit of complication here, but not much. This 6 is not attached to the x. This x is attached to the negative 3. The 6 is just multiplying it. Technically, the 6 has an invisible 1, at least for the exponent, right? So this 6 does not have a negative exponent. That's the thing. We need to make a negative exponent go away and become positive. So Draw your fraction bar, have the x that's attached to the negative exponent drop down and become positive, no problem. What's left upstairs? It's that 6, and that's all that we have to do. Same thing's going to happen right over here. N to the second power drops down, and that 5 is just going to wait right there for us. So you're going to have a worksheet tonight where it's going to ask you to do two things. One, it's going to ask you to write each expression using positive exponents. That's easy. Evaluating, we just take it a little bit further. So let's go through this one. Can you please write this as a positive exponent? Remember, keep the parentheses around your base if they're there. Now, for the evaluating, basically, let's see if we can get rid of all exponents, but first off, make that a positive exponent. So if it said write it as a positive exponent, we would be done right here. But it's saying evaluating, and since we can figure out what 5 times 5 is, go ahead and progress to the next step if you're in this type of situation. So 8 to the negative third becomes 1 over 8 to the third. And then we just find out what 8 to the third is. In this case, it's 512. So these negative exponents, they do not mean that it's a negative number. It just really means that it's a small number. And then this last one, hey, look, evaluate. We have variables here. What if they tell us what the variables are? So plug them in. It would become 6 to the negative second power. Make it into a positive exponent by putting it below. And just work through what 6 to the second power is 36, so 1 over 36.